So, 2-4, application of trig functions. First thing, just a reminder, what is our sine equal to? Sine is what? It's right over there. Opposite over hypotenuse, correct. What's cosine? Adjacent over hypotenuse, correct. How about tangent? Opposite over adjacent. All right, those three things are going to help us to figure out missing sides, missing angles, whatever we might need. Okay, the ones that we did on the warm-up were missing sides. We're going to use some missing angles ones based off of our inverse trig functions we talked about yesterday. But before we get started, we have one right triangle there. We're going to solve this right triangle. So when it says to solve a right triangle, what you want to do, you want to figure out all three sides, all three angles for the triangle. Based on what I have here, and this is a right angle. Okay, so based on what I have here, I know two angles already, don't I? Let's knock those out real quick. So first off, what's angle A equal to? 34.5. Angle B is, we don't know. C is 90. So we have two just already written down, don't we? All right, so let's think back. What do we know about a right triangle? Or any triangle has interior angles, they sum to 180. So if I want to find angle B, I just have to do what? Add them, subtract from 180, or just subtract off, right? 180 minus 34.5 minus 90 is going to be what? 55.5, correct. So angle B is 55.5. All right, so we have all three of our angles now. So let's move on to the sides. We're given one so far. Which side do we have? We got B, and it's 10.5. There's no units, but it's just going to be 10.5. All right, now we got to find our A and our C. If we have two sides of the triangle, then we can use what? Exactly. If we have two sides, we can use Pythagorean theorem. This one only have one. But we know the angles, so we can use a trig function, right? Let's use this angle that we already have right here, and this side that we already have. So if I'm looking at this guy, and this is my reference angle here, 34.5, this is adjacent side. So now I'm looking at either cosine or tangent, right? Which one do you want to find, C or A? C? All right, let's find C. So if we want to find C, now we have to use cosine. We have adjacent, we're looking for hypotenuse. So we're looking at these ones. So I have the cosine of 34.5 degrees is equal to the adjacent, which is 10.5, over x, or C, whatever you want to put there. So then to solve this guy for x, looks like we're going to have to multiply both sides by x. Get rid of the fraction. And then we'll have to divide both sides by cosine of 34.5. So then, therefore, x is going to be 10.5 divided by the cosine of 34.5. What's that going to be? I'm going to punch that in a calculator for us. 12.7. I agree. So then C is 12.7. Now, I could use another trig function if I wanted to, or use Pythagorean theorem. Let's go ahead and use Pythagorean theorem just because we're reviewing a little bit here. So Pythagorean theorem, what is a Pythagorean theorem? Okay, a squared plus b squared equals c squared. What's c squared going to be? Which side? C, the single term, is always your what side? Hypotenuse, correct. All right, so a squared plus b squared equals c squared. We know our one side, which is our b, so we have 10.5 squared equals c squared, which is our hypotenuse, which is going to be 12.7 squared. It's 12.7 squared. Anybody? 161.2. What's 10.5 squared? What was it? 110.25. Okay. Now we're looking for a, so we subtract that over. So we have a squared is equal to 161.2 minus 110.25, which is going to be 51.04. Okay. And then what's the last step? Square root both sides. So A is going to be, give it to me to the nearest tenth. 7.1. Okay. 7.1. All right, so there, using a trig function, using sum of interior angles, and using Pythagorean theorem, we were able to figure out all three sides, all three angles to that triangle, and we were given one side and one angle. All right? Just figure out what you have, figure out what you need, and then decide which theorem or property you need to use for it. All right? All right, here we go. We're going to do two problems. So what we're going to do a series of problems here. The first two we're going to look for find the side, which we did in the warm-up. Second two, we're going to look for an angle. We're going to do one together, and you got one on your own. All right, so first one. From a point level on the ground 125 feet away from the base of a tower, the angle of elevation is 57.2 degrees. Approximate the height of the tower to the nearest foot. So, angle of elevation. We talked about angle of elevation, angle of depression. If I'm looking here and I look up, is that elevation or depression? It's elevation. That's whatever angle I have from flat to up to the top of it. Angle of depression is looking out flat down to whatever I'm looking at. Okay? So looking at this guy, let's make a triangle. So I'm looking to this point here, right? Here's the ground. And I'm just going to turn this into a right triangle. So I know this. I know my angle. I know how far I am from the base of the tower. I'm 125 feet from the base of the tower. I know that my angle of elevation is going to be 57.2 degrees. Okay? Right there creates my right triangle. Now I'm looking for the height of the tower to the nearest foot, correct? So I'm looking for this side over here. So looking at this triangle, I have one angle, one side. I'm looking for the opposite side. I'm looking for this one. So based off of this being my reference angle, what two sides am I associating this with? Opposite and adjacent. Opposite and adjacent, which what's trig function? Tangent. There we go. So I'm going to have the tangent of my angle, which is 57.2. Tangent is opposite over adjacent or adjacent over opposite? Opposite over adjacent. So what's my ratio here going to be then? X over 125. Good. All right. So solve for x, what do I need to do to both sides? Multiply by 125. Correct. That's gone. All right. So now it's just calculator time. Tangent of 125. Tangent of 57.2 times 125 is going to be what? 193.96. Okay. And it says approximate the height of the tower to the nearest foot. So what would our final answer be? 194 feet. Correct. Questions on how we did that and set it up? Anybody? That's not awful, no. These are fun. All right, so here we go. Second one. Same type of concept. You're looking for a missing side. I'll give you about 3 minutes or so to try that one on your own. here. So we have the Eiffel Tower. We would have a triangle that looks like this, right? Now, we are 80 feet away from it, so we're not super far away from it at all. And if you look, we have an angle of 85.4 degrees for our angle of elevation. We're looking all but straight up in the air, aren't we? I mean, think about it. 90 degrees would be here. What's this, 85? So I'm probably about here. Okay? That's all the difference. So I'm basically standing at the base of this thing looking straight up in the air. So I'm looking for the height, which is this side over here. I know my adjacent side, so therefore it has to be what trig function? Tangent, correct. So I have the tangent of 85.4 degrees is equal to what over what? X over 80, correct. All right, x over 80. Then I have to multiply both sides by 80. Let's punch that in the calculator. 80 tan at 85.4 is going to be 994.3. Does that sound right? Okay, and then the final answer is 994 feet. I looked this up whenever I was making this because I stole this problem from the book. I looked it up just out of curiosity. I think it's actually 986 feet. Is the real Eiffel Tower. But that could be the difference in where they started at. If there's a little concrete base, you know. All right. All right. Any questions on that problem, guys? All right. Let's move on now. Finding the angle of a right triangle. So in the first two, we found a missing side. Now we're going to find a missing angle. This is going to bring in what we did yesterday with the inverse trig functions. So we have a kite flying at a height of 30 feet when 65 feet of string is left out. If the string is in a straight line, find the angle that makes with the ground to the nearest tenth of a degree. So let's draw a picture. Okay. First thing, I remember I told you this last chapter. Anytime you're doing problems like this, draw a picture. All right. So here's the ground. We got Sodmon out here. He's flying his kite. Right? Okay. So here's my kite. Okay. Just flying in the breeze. You like that? That's very accurate. Very accurate. Yeah. Yeah. I figured. Yeah. All right. So there's our kite flying. It's 30 feet above the ground. So this is 30 foot tall. All right. How much string do we leave out? 65 feet. So we want to know what angle this thing makes to the ground. And, you know, you're holding the string out in your hand. So we are looking for this angle right here. That's going to be our theta. Okay. Now looking at this guy, I created a right triangle based on my picture. What two sides do I have? 30 to 65, opposite and correct. Which function is that? Sine. This is sine. So I have the sine of theta is equal to my opposite side, which is 30, over hypotenuse, which is 65. Now, if you remember, we cannot just divide by sine here. Okay, theta is attached to the sine function. We can't just divide by something like that. But based off of yesterday, I can rewrite this guy as the inverse sine of 30 over 65 is equal to theta. Okay, this is what we did yesterday. You can rewrite a sine into an inverse sine to get that theta by itself. Now it's saying what angle has this ratio of sine. So then you punch that in your calculator. You probably have to put second sine, or if you're using your cell phone, you have to slide over to the side and you hit the inverse button, the INV. Okay. If you have this is just the standard cell phone calculator, if you slide the bar out from the right side, you hit INV, then you hit sine. That should be the inverse sine. Punch that in your calculator. You should get 27.5. Take a minute, punch that in your calculator, make sure that is what you get. For those blue calculators like that, a lot of times you have to put in the inverse sine, so it'd be second sine And then the easiest way to do it, you're going to get something like this. Then just put 30 divided by 65. Enter. All right. Sometimes if you put the ABC button in to make it a fraction, it doesn't always like it. But if you put that in right there, inverse sine of 30 divided by 65, you should get 27.5 roughly. Who was able to get that? Yeah. Okay. Cope, did you get it? Okay. Linda, did you get it? All right. Megan? Yeah. So yours, you have to put the number in first and hit second sign. Okay. All right. Questions on that one? Anybody? All right. Next one's going to be for you. So guy wire. First off, does anyone know what a guy wire is? Okay. You ever see the big, tall like cell phone towers? Cell phone towers. There's a whole bunch of wires like tying it into the ground, keep it from flying back and forth. Those are called guy wires. Okay. So a guy wire is 13.8 yards long, is attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that the wire makes with the ground. Give you a couple minutes to try that guy. Set up this triangle right, then everything else is really easy from there. Okay? Oh, crap. So, guy wire is 13.8 yards long. It's attached to the ground to a pole 6 yards above the ground. Here we go. Pole, wire. Pole is 6.7 yards. wire is 13.8. Here's my right angle. Here's my reference angle. Okay? If you didn't have it set up right, then you're off to a bad start here. So now, based off of this, what two sides do I have? Opposite and hypotenuse, correct. Which function? Sine. So now I have the sine of theta is equal to opposite, which is 6.7, over hypotenuse, which is 13.8, right? Now from there, I have to go inverse sine of 6.7 over 13.8. Punch that in the calculator, what do I get? It should be 29.0 degrees. Okay, 29.0. Did you put cosine possibly? Make sure you typed it in right. All right. This is another one too. I think someone else had the 13.8 on top and 6.7 on the bottom, and then they gave you an error message. Okay. It was all in the setup on these. Ready for the next one? Questions? All right. What happens if we have to use two right triangles? This one's kind of fun. We'll do this one together. I'm not going to give you one on your own for this. Probably be one on the homework. So if you're using two right triangles to solve a problem, you're taking your first hot air balloon ride. Anybody ever been in a hot air balloon? You seen them? I don't want to get in one. I'd be afraid it'd be a hole pop whenever I was in the thing. It wouldn't end well. I mean, you ever see the Zeppelin? Heard of the Zeppelin? Or the Hindenburg? All right, here we go. So you're taking your first hot air balloon ride. Your friend is standing on level ground, 100 feet away from your point of launch, making a video of the terrified look on your rapidly ascending face. We want to know how rapidly it was ascending. So at one instant, the angle of elevation from the video camera to your face is 31.7 degrees. 1 minute later, the angle of elevation is 76.2 degrees. How far did you travel to the nearest tenth of a foot during that minute? There's a lot of stuff going on here, isn't there? All right, let's draw our picture. What? What do you mean? I'd put a little spice in it, you know? All right, so here's the ground. So Emma, since you're the one trying to make fun of the problem, you're going to be the one in the hot air balloon. Okay? Well, that makes sense then. Your terrified face. Okay, so Emma is in the balloon. All right, so here's our balloon. There's a little basket in it, and Emma's in there. Okay? Very accurate picture, like always, right? All right, so then who's standing on the ground taking a video of you, making fun of you?
Probably Avery.
Avery? Okay. So we got Avery right here. All right, so Avery's right there. She's watching you in the balloon. Now, we're assuming that your balloon just went straight up in the air. Okay? There's no wind blowing it back and forth. We went straight up in the air. So here's your path of ascent. All right, so at one point, Avery's taking a picture of you, taking a video of you. And you would, oh, that's not even close to being a straight line. We're going to try that again. All right. So there's the first time she checks you. All right. And then a minute later, holy cow, I cannot draw straight lines today at all. Are they? All right. Maybe I should get you to come up and draw them. So there's my second triangle. We'll pretend that's a straight line. It's a little wavy. It's more like a sine function, doesn't it? All right. So now I have two right triangles, don't I? The first right triangle is this one right here. The second one is the entire thing. Now, in the problem, it says we want to find out how far you traveled during that 1 minute. So we want to know what the distance is from here to here. We don't need this whole distance. We just need this distance, right? We know this distance on the bottom is 100 feet. That's the only distance we know so far. But we have two right triangles with two angles. So we can figure this first triangle out. We can figure out this side, right? Then we can use the big triangle to figure out this total distance, and then just subtract them. Yeah. All right, so let's do that. So the first one I have is 31.7 degrees. So I have the angle right by the video camera. 31.7 degrees, and I'm looking for the opposite side. So now I have the opposite side, and this would be what side? Adjacent. Opposite and adjacent. Yeah. What trig function? Tangent. What tangent function is it? Tangent. All right, so I have the tangent of 31.7 degrees is equal to the opposite side, which is x, over the adjacent side, which is 100. All right, solve for x. I have to do what to both sides? Multiply by 100. So I'm going to have 100 times the tangent of 31.7. Punch that in a calculator. What do you end up with? 61.7. I guess 61.8. Okay. All right, so 61.8. Okay? That is this distance right here, 61.8. From the ground to the first checkpoint, essentially. Now let's find our distance at the end of it here. So at the top, I have the same setup again. Now this angle is going to be 76.2 degrees. And I'm looking for the opposite side, which is from here to here. Let's call that y. So I still have the same two things. I have the opposite side and the adjacent side, don't I? So I just replace the angle and do the tangent again. So 76.2 is equal to the opposite side, which I call y, over 100. Multiply both sides by 100, and what do you get? What'd you get? You didn't mess up. So 407.1 is what I have. Okay? So at that second point in time, this is 407.1 feet. So we were worried about how far we changed during that 1 minute. Okay? So we just got to take 407.1 minus 61.8. What does that give us? 345.3. So in that 1 minute of terror, 345.3 feet. Questions? Anybody? All right, let's go on to the last section for the day. We got a few minutes. We can at least do one of these problems. So trigonometry and bearings. Anybody know what a bearing is? Off the type it's in your wheel. All right, how many of you guys have ever watched like a movie that has like the Navy or the Air Force and they say a bearing is north 30 degrees west or south 20 degrees east? Those types of things. That's a bearing. How many of you guys ever knew what that actually meant? You just went, all right, they're probably going north somehow, right? All right, so how's bearing work? Bearing works like this. When you write a bearing, you have a direction, an angle, and then a direction. Your first direction is always going to be north or south. Then you have your angle from your y-axis. Okay, your y-axis is your north and south axis. Then you have an angle off of that axis, and the second one is going to be your east or west, and it tells you which way to go from there. So, for instance, just drew a compass on here for you. If I have this angle, okay, this angle, I'm going to say it's 30 degrees off of north. We want to write that as a bearing. So you start, which is the closest, north or south, to the angle or to the line I just made? It's north, right? So we're obviously starting north. So that would be north. Now then I have my degrees away from that y-axis. How many degrees away is it? 30 degrees. So it would be 30 degrees. Now which direction is that in? West or east? East. So that bearing would be north 30 degrees east. That makes sense? Okay? So basically it's saying I started going north and then I turned 30 degrees to the east. Okay? All right, let's do another one. if I have this guy, here's where it gets a little bit tricky. So say this angle here is, we'll say 20 degrees. Okay? So I'm 20 degrees off of west. Right? But I don't say west 20 north, do I? Because everything has to be north first, north or south first, and then east west at the end. So I'm going to be starting, which one, north or south? North. Now, this is 20 degrees from here to here, but that's not what I want. I want my degrees off of my y-axis. Okay, so from here to here is 90 degrees, correct? So what is this angle from here to this line? 70 degrees, correct. So it would be north, 70 degrees, which direction? West. All right, let's do one more. Let's use that guy. Say I'm 75 degrees off of east. So now, what would be my bearing for this one? South. How many degrees? 15, because it's 15 away from the y-axis. And then, perfect. So south, 15 degrees east. Does that make sense? Okay, let's use that in the problem. We got 2 minutes. We got time. I want to do this problem yet. Otherwise, you'll be lost on your homework. So a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. Captain then turns the boat 90 degrees clockwise and travels 18 miles on a bearing of 48 degrees east at that time. How far is the boat to the nearest tenth of a mile from the harbor entrance? What is the bearing to the nearest tenth of a degree of the boat from the harbor entrance? So, we were going northeast, correct? All right, it sounds like there's a lot. I agree. It's kind of a confusing thing. Just break it down to pieces. So we're going north and then east. So we'd really be in quadrant 1, correct? So that's the only one I need to draw. So right here would be the opening to the harbor. Now I went north and then 30 degrees, 42 degrees. 42 degrees east. So right there would be my travel line. Now I'm 42 degrees off of the y-axis, correct? Now then I get out there, and I'm going to make a 90-degree clockwise turn. So if I'm here clockwise, would I be going right or left? Right. I'll be going right. Okay? That gets me to there. 90 degrees is there. And I went how far? 25 miles to start, and then 18 miles. Okay? So then I'm going to stop right there, and I want to know what this distance here is and what that bearing is. Okay? Give me 1 minute. So right now I have my right triangle, don't I? Okay? I have my right triangle. I have two sides. I can find the Pythagorean theorem. So Pythagorean theorem, this is my hypotenuse. I'd have x squared equals 18 squared plus 25 squared. Just bear with me, I'm going to give you the numbers. X squared equals 949, square root both sides. X is going to be 30.8. It's going to be 30.8 miles. That would be that distance. Okay? Now I need this angle right here. I'm looking for this guy right here. Because I already know what it is from here to here, I can add those two together then, right? So this is going to be, I have my opposite and I have my adjacent side. So I can go the tangent of theta is equal to 18 over 25. Now I'm looking for the angle, so I do the inverse function. So the inverse tangent of 18 over 25, punch that in, I get 35.8 degrees. So this is 35.8 degrees right there. Now, my bearing has to be off of north. So I just add these two together, 42, 35.8, and I get 77.8. Therefore, my bearing would be north 77.8 degrees east. This is how, you ever watched videos like, or movies like CSI or, criminal interest, those types of things? You ever hear when they triangulate a position? This is exactly what they do right here. All right, guys, there'll be a homework assignment up over the weekend. It's like 8 problems. Have a good weekend. I'll see you on Monday. If you're Fourth period teacher is mad that you're late. Tell him to talk to me. Okay, we'll blame it on Mr. Estep. That works.